Hello everyone, I'm Sebastián Ramírez and I'm gonna tell you a little bit about FastAPI. So let's switch to this view. We're gonna do an intro to FastAPI, which is a Python framework for building web APIs. It has high performance, it's easy to learn, it's fast to code, and it's ready for production. And we're gonna do all that with Docker. So first, a little bit about who am I? I'm Sebastián Ramírez, or Triangolo. I live in Berlin, Germany, but I'm actually from Colombia, South America. That's why the accent. You can find me on GitHub, LinkedIn, Twitter. And I'm currently a staff software engineer at Forethought. And additionally, I am an external consultant helping other teams and other projects. I created FastAPI, Type SQL model, and a bunch of other open source projects, and that's why I'm here with you today. Well, that plus I'm a huge fan of Docker for a very long while. So let's talk a little bit about FastAPI. FastAPI is a Python web API framework. It has around more than 40,000 GitHub stars. It's been growing around 1,000 stars per month, so that means that people have been liking it, it seems. It's currently used by Microsoft, Uber, Netflix, and a bunch of other companies and projects. And the performance is in the top rank for Python, so it's in the ballpark of the best that you can get with Python, and it's the third most used Python web framework right after Flask and Django. This is by the official Python developer survey, and is the third most loved web framework by the Stack Overflow developer survey. And in this survey, they mixed backend and frontend. This means that FastAPI was right on top of React and Vue.js, and those are amazing technologies. So it's amazing that people can like FastAPI so much. This is what we are gonna talk about today, or what I'm gonna tell you about today. So FastAPI is based on standards like OpenAPI and JSON schema and OAuth 2. This makes a lot of interoperability between different tools much easier. For example, we can get automatic API docs like the ones that we see here from the standard FastAPI code that we write. And it's also based on standard type annotations, so the standard way that you declare types in Python. This means that we get like a bunch of features from that, like autocompletion and inline errors and stuff like that, but we also get automatic data conversion and automatic data validation and automatic data documentation. We're gonna see a little bit about that. But the thing is that FastAPI is all based on standards, and that means that you get standards for free. Cool. So FastAPI is based on Python type hints. This means that we declare type annotations. For example, this one we are saying, hey, name is a string. And this is the standard way in Python to declare that this variable, this attribute of this class will be a string. We are not importing some particular class from FastAPI or something. This is just like the standard way to declare that something is a string. FastAPI uses all these standard type annotations. Here we are saying, hey, this parameter is an item, which is an instance of this class item. If you notice, this is a colon, this is not an equal sign, so this is not the default value. This is the type annotation saying what is the type of this variable. And this is again the standard way in Python to say that this will be an instance of this class. So it's not the class, it's an instance of the class, but we're going to see a little bit about more about that later. This is what provides autocompletion everywhere, like this one, because the editor knows that item is an instance of this class. Now we get autocompletion for the attributes that we defined here, and we get type checks and type errors everywhere. This means that we have autocompletion everywhere in the code. FastAPI was designed to provide as much as autocompletion as possible throughout the code base. So FastAPI is easy and short. That's the idea, that it should get out of the way. This is a valid FastAPI application. You can see it's 1, 2, 3, 4, 5 lines of Python code. This is already a complete FastAPI application. The point is, the more FastAPI code you write, the less API code you write, because you can focus on the business logic, on the important parts of your application. You can focus on the things that matter. And the API code will be minimal because FastAPI will get out of the way and do a lot of the best practices by default. So let's check a basic FastAPI application. So from FastAPI, we import this class, FastAPI, then we create an instance of that class, of that FastAPI class. And then with this instance, with this app, we can decorate some functions. And to decorate is to use this @ symbol, and then we say, hey, app, whenever someone sends an HTTP GET request that goes to the path /, so this is the root path, I want this function to be the one that handles that request. So a decorator, something like this @ symbol, what it does is that whatever is here on top will modify in some way, or will use in some way the thing that is below. In FastAPI, we use that to add the functions that will handle different requests and send responses. Then we can say, hey, whenever someone sends an HTTP GET request that goes to /items/, and then you can see that this has the curly braces around, so this is going to be a path parameter, then some other value here. This is the function that will handle that. And then FastAPI will extract the parameter from here and will put it in this parameter. This path parameter will put it in this function parameter here. So this could be the URL that we are using. Let's say that our application leads at https://somedomain.com, then /items, this is the same as /items, and then these will be the item ID, which is this path parameter that we define. And now we are saying that this item ID should be of type integer. FastAPI will make sure that this is of type integer. Now we are also saying, hey, I also want to have this Q parameter, which is of type string, and by default it's none. So FastAPI will extract this Q. We'll see that, hey, this Q is not in the path, so it's gonna read it from the query parameters. So these parameters that go after the question mark. So when a user sends, hey, Q is equal some query, then we will have this some query inside of this parameter. And because this Q has a default value, in this case it's just none, then Q is not a required parameter. And now with this very simple application, if we go to /docs, then we're gonna have this automatic interactive API user API documentation, or API user interface that shows the whole API that we wrote in code. We can see that we have the get to the root path and get to /items with the item ID. We can see that item ID is declared in this documentation as an integer, because that's what we defined in the code, and that it goes in the path, and that we also have a query string, which is optional, this is not required. This query string, which is a string and goes in the query with the parameter Q. Nice. So you write some basic code, and good guy, FastAPI makes a docs user interface for you. Now let's say that we want to create a FastAPI application with a body. So we're gonna do, it's very similar to what we did before, but now we're saying, hey, app, whenever someone sends a post request, an HTTP post operation or an HTTP post method that goes to /food/, this is the function that I want to handle that request. And then we say, hey, we have this parameter food, and this is of type an instance of the class food. And this class food is created here. So let's check this out. FastAPI is based on two projects. One is Starlet, that handles all the web parts, and the other one is Pydantic, that handles all the data parts. This does all the data validation, data serialization, data documentation, all that stuff. So from Pydantic, we're gonna import this base model, and then we're gonna create a class that inherits from that base model. And then in this class, we just define the attributes that we wanted to have, the fields that we want for that Pydantic model, and we define the types with standard Python type annotations. And you can see we don't have to declare an init method or anything like that. We just declare the types of the attributes and maybe default values, and that's it. That's all we have to do. Pydantic takes care of the rest. So now we're saying, hey, I want to receive a model. In this case, this will be interpreted as a JSON body payload that will have a name that is a string, and will have an ingredients field that is a list of strings. Again, this is the standard way that you will declare lists in Python. And this list comes from typing. So you will import from typing, import list. Typing is part of the standard library in Python. So this is again the standard way to declare the type annotation for ingredients. If you are in Python 3.10 or above, you can use the lowercase list, so the default Python list in the same way without importing it here. But if you are in any previous version, this is what you will do. And now we're saying, hey, ingredients will be a list of strings. Also notice that this is not parentheses, this is square brackets. So this is the type of notation that you would use with types for Python. We declare that, and then FastAPI will make sure that this parameter will be an instance of this class with the types that we defined here. And then we can use that instance, and it will have the attributes, the fields that we defined, and we can use them internally. Now, if we go to the same documentation site, to the same API docs UI, we will see that now we have this post that we created that will receive things at /food/, and we even have an example generated automatically from the data that we declared. So it shows that name is a string and ingredients will be a list of strings, or in JSON terms it will be an array of strings. And now notice that this is the data that we define. This is not something that comes from FastAPI that we imported in FastAPI, some type of object that we can receive from FastAPI. This is the model that we created, and we get auto-completion. Well, we're going to see auto-completion in a bit, but we get the automatic API documentation from those definitions. Now, we can actually try to run a query in the same docs UI because it's interactive. We can actually send a request. So we're going to say, hey, the name of the food that I want is a taco, and the ingredients are frijoles, carne, taco shell, and sabrosura, of course. And then if we execute this request, it's going to send it to the server that is running live while we are writing the code. And it's going to execute it, and it's going to take it and send the response back. So we can interact with our API live from this automatic and interactive user interface or documentation site for our API. And then we can send requests with tacos, which is very nice. Now, let's say that in our FastAPI app, we want to have a body, but we also want to have a query parameter. So again, the only thing we have to do is just use again the same parameters that we were using and the same type annotations. So we are saying, hey, food is an instance of the class food, but I also want to have another parameter in this function, which is called delivery, and delivery will be a boolean, and by default it will be false. So FastAPI will say, hey, this delivery, this is not a pedantic model, so FastAPI will not read it from the body. It will see, oh, this is a simple value, so I'm going to read it from the query parameters. And then it's going to check and make sure that this is actually a boolean, and then we're going to receive a boolean here internally. And it will make sure that we receive an actual boolean value. If we will not receive a string with the word false or something like that, we will receive an actual boolean. And if we go to the documentation, because we define that it's a boolean, then the user interface will even help us and show, hey, these are the only options. It's just true or false. This is all we can do. And it knows that it's in the query parameters, and it knows that it's a boolean. This is how the URL will look like if we use this new query parameter delivery. We'll say, hey, delivery equals true. Now, notice that we are passing this query parameter in the URL, and the URL is intrinsically a string. So this is, by default, this is just a long string. But FastAPI makes sure to convert the data to the types that we define. So it's going to parse this true, and it's going to convert it to an actual boolean in our code. So in our code, we will receive the types that we define, even if they are extracted from some places that are naturally just strings. And now with that, you don't have to put everything in the body. You can put the query parameters in the query parameters, and you can modify and receive information in the request from multiple places. Now let's say that we want to have a JSON array of objects in the body. So it's not one single JSON object. We want to have an array of objects. To declare that, we just do the same thing that we did before. We use the standard Python type annotations. Now we're going to say, hey, we're going to receive orders, and orders is going to be a list of instances of this class food, and FastAPI will make sure that this is what we receive. Now in the parameter orders, in this variable that we have inside of our code, now we can iterate for each one of the orders there. And because FastAPI is making sure that the data that we receive is the same type that we define, then each one of these food items is going to be effectively an instance of the class food. So we can iterate for each one of these food, and then we can extract the attributes that this instance is going to have, like food.ingredients, and then for each ingredient, which is going to be a string, because this is what we defined here, then we can do something with that and then just return the response. The thing is that we can work with our data with the exact same types that we define, and this is very useful. I'm going to show you in a little bit why this is very useful while coding. But first, now let's see the interactive documentation. It's updated, and now it shows that effectively we are receiving an array, a JSON array, or the equivalent of a Python list that has the same type of objects that we define, and that's all we have to do to have JSON objects inside of an array. And we can define, with that we can define very arbitrarily complex data structures for the payloads that we want to receive. So if we want to send JSON and we want to put the JSON inside of the JSON, however we want to mix and match the data that we want to receive, we have all the flexibility, and it's all based on standard Python type annotations. Now, what happens if we send invalid data? So this is a request payload, and this is all valid JSON. So it's not that there's a comma missing or something like that. If there was a comma missing, then FastAPI will also show an error to the client. But let's say that this is valid JSON, because it is, but it's not valid with the data types that we define. Let's see how is it that is not valid. So the first element, this has a name, which is what we said. Taco ingredients, each one of these ingredients is a string, so this is all valid, that's fine. The first element is actually valid. The second element, and this is like a list of elements, a list of JSON objects, an array of JSON objects, or like a list of dictionaries if we're talking in terms of Python. Then the second item has a name, which is pizza. This is a string. This one doesn't have ingredients, but we say that ingredients had a default value of an empty list. That means that ingredients is actually not required. So this means that this one is not required. Cool. Now we also have this one, this element. It has a name that is called Trojan food, and then in the ingredients is effectively a list or a JSON array, and the first ingredient is actually a string, so the first ingredient is actually fine, but the second ingredient is a JSON object. This has some name, a sneaky object, something like that, but this should have been just a simple string, and this data is invalid by the things that we defined that we wanted to have, because this is not a string. But you can see that this is deeply nested inside of the data structure. It is inside of the ingredients, which is inside of the food item, which is inside of the list of food items. So this thing is invalid. Now, the last one, this one doesn't have a name. This has a food_name. So this doesn't have the required name that we saved. Now, let's say that we execute this query. What happens? Then FastAPI is going to send the response to the client automatically, validating the data and telling the client, hey, the data that you sent is invalid. And it's not only telling the client, hey, you sent invalid data, it's telling the client exactly where the invalid data is. So it's telling, hey, in the body, in the orders, at index 2, because we start at index 0, so index 2 will be the third element. In the ingredients at index 1, so the second element, a string type was expected, and remember that this was a JSON object, not a string. So we get very clear information telling us exactly where the problem is, and it's also telling us, hey, in the body, in orders at index 3, in name, the field was required, and we didn't have a name, we had a food name or something like that. So we get like all the validation. It's not only validating that the data is exactly the shapes that we defined, it's also telling the client exactly where the problem is. So this saves a lot of time in debugging and developing for FastAPI applications. So without valid data, FastAPI will protect our code from running with invalid data, but with valid data, everything will just work exactly as we defined it in the types. Now, because of that, because it's all based on standard Python type annotations, we get autocompletion everywhere. Notice this, we have a double nested for loop. So we are getting each one of the ingredients in each one of the food items in each one of the orders, and still we get autocompletion for each ingredient because the editor knows that the ingredient is a string. And it knows that because we defined all that in standard type annotations. We said orders is a list of instances of the class food, and the class food has a field ingredients or an attribute ingredients, which is a list of strings. So each one of these ingredients, which is here, is a string, and the editor can know that and can give us autocompletion for all that. And we also have type checks or inline errors in the editor, because it also knows that the ingredient is a string. It can tell us, hey, you cannot sum a string with an integer because this is not valid, it's unsupported. So we get a lot of help from the editor just because we are using the standard type annotations. We don't have to learn some new syntax, it's just the same standard syntax for Python, and we get all the features from the editor, and on top FastAPI does data validation, data documentation, data serialization, and all that stuff. And this is all based on standard Python types. Nice. Now about the performance stuff. So this is a benchmark run by Tech Empower, which is a third party. The green lines are Golang, which is a compiled language, and the blue lines is Python. Of course, Go, by being compiled, has to be faster than Python. But you can see that FastAPI is on the ballpark of the things that the fastest things that you can get with Python. In fact, it can even be a little bit, can have a little bit of better performance than some of the Golang frameworks. Which one is exactly the fastest is not necessarily that exact, because in fact here below FastAPI is Uvicorn, and Uvicorn is the server, it's not even a framework. Uvicorn is running each one of these, so Uvicorn actually should be on top of everything. So this has some random error, but the fun thing is that you get on the ballpark of the best that you can get, and like you can fine tune it to have like a very good performance. For example, in here this is 15,000 requests per second, something like that, and that means that it's over 9,000, so that's great. Now a little bit about FastAPI with Docker. How do you make a FastAPI application in Docker? This is a very simple Docker file, and this is all you need. So from Python, from standard Python 3.10 in this case, we just say, hey, we want to work in this working directory /code, and now we want to copy the file requirements.txt. If you have another package manager, another package to handle the requirements of your application, it could be Poetry, it could be pipenv, it could be piptools, something else, whatever. You will just copy whatever that file is, and then we just copy it to /code/requirements.txt. Then we install those requirements, and then we copy our code, and then we just run the command to start the application. So we are telling, hey, I want you to run Uvicorn. Uvicorn is the server, as I was telling you, is the server that will run our FastAPI application. And we are telling it, hey, run the Python package app. So this refers to this app. And inside of that, the Python module main. So this will refer to a file main.py. And then inside of that, find the object app. And the object app is the same app that we were creating with FastAPI. So this is what this means. And then we're telling it, hey, listen on all the IPs. So this means listen on all the IPs, because otherwise it will be listening only inside of the same Docker container, and nothing will be able to talk to that container. So we're telling it, listen to all the IPs and run on port 80. That's all we have to do. And now we have a completely valid Docker image for our application with all the benefits that we get from Docker, like security, isolation, dependency management, replicability. There are just too many features to list here. So this is what you will normally want to do. This is what you will do if you have Kubernetes or other orchestrators like Nomad or Swarm Mode or a bunch of others. Or if you're running on cloud services that run your containers and your images for you, or on small devices like Raspberry Pis or something that has a different architecture. For example, Raspberry Pis have an ARM architecture, an ARM processor. So this is what you will do in those cases. This is what you will do in most of the cases. In some cases, when you're doing, for example, manual deployments, so for example, running manual Docker commands or bash scripts that just start the containers directly, or in Docker Compose or with some other custom use cases, you can use this, let's say, official Docker image. Well, it's the official Docker image, it's the only Docker image for FastAPI that combines Uvicorn with Unicorn. And then you just do the same thing, copy the requirements, install the requirements, copy the code application, and now we don't add the command, the explicit command, because the image takes care of running like all the command and do all the magic to run Uvicorn through Unicorn and start multiple processes and handle memory and all that stuff. You can read more about that in the documentation for this Docker image, but the thing is that it will start multiple processes and handle that, and that will be useful if you need for some reason to run a single container. But if you are running on Kubernetes or on some cloud service, some function as a service, or some container as a service from one of the cloud providers, then you will probably use the previous option that I just told you. So this is only for the manual deployments, just running Docker commands in a single server, and you can only run a single container, or if you're running Docker Compose, which is also just a single container, or some more custom use cases. But for in general, you will use the other option. These are the main two options that you will do for FastAPI, but it's actually super simple. It's just like a very small Docker file, and now you have a completely valid FastAPI application in Docker. Now let me move myself here. Yeah, nice. You can read more about that in the FastAPI documentation. There's a lot of documentation about how to do FastAPI with Docker and with containers, and you can check more about that there. Now, FastAPI also has some other features like dependency injection. Let me move myself back to the top. Yes. Dependency injection, security with through WebSockets, files, background tasks, easy GraphQL integration, a bunch of other features, templates, like everything that you will probably expect from a web framework. But yeah, you can also go and check all that stuff in the documentation. Here's the documentation. You can go and check that out. And thank you very much for having me.